Welcome to The Siliconomist. I'm joined today on The Siliconomist by Nursultan Kabylkas. Nursultan wears many different hats in the semiconductor ecosystem, but we're going to explore two today. First, Nursultan's a professor here in Kazakhstan, Nazarbayev University. In 2025, last year, he and his students created the first semiconductor designed in Kazakhstan. Super interesting story, and excited to dive into that. And second, Nursultan's also the founder of two startups working on AI, or one that's kind of merging into another. He founded Texer.ai, which speeds up verification and validation on semiconductor designs and has an educational component. And recently, he and some colleagues founded RISC-V, which is interesting. I'll let him explain that, but it's about LLMs and finding truth within them. So,
Right.
Nursultan, welcome to The Siliconomist.
Thank you so much. I appreciate it. Glad to be here.
A pleasure to have you. I know you split time between the Bay Area and Astana. Your first name is Nursultan. Astana used to be called Nursultan until recently. So you're Nursultan from Nursultan. But
Yeah.
now Nursultan from the Bay Area. So a little bit of background. We met at CEVF, Central Eurasian Venture Forum, in person last year. I was on a panel talking about investment, and I think you were listening, and I think you spoke as a startup as well. But the panel I was on was stacked deep with VCs that were talking about AI software and vibe coding. And I made some slightly condescending remarks about how everyone on the panel was investing in AI software bubble, I think. They were all ignoring the hardware that supports it. And I think that went over graciously. Everybody kind of ignored it, but you came up and talked to me afterwards. I think that got you hooked.
Yeah, exactly.
And then afterwards we started talking about semiconductor design and verification of the work you were doing up at the university in Astana. So I've been here in Almaty for the last year and a half, and you seem to be connected to everything that I've seen in Kazakhstan that's semiconductors. There's not a lot here for now, but it sounds like you're out there laying the seeds for more to come. So before we dive too deep on anything, I was kind of researching you. I saw on your Instagram that you had this post. It was my journey began in fifth grade when my dad took out a loan to buy our first desktop computer, and then somehow magically you went from that. It sounds like a really awesome, humble beginning in fifth grade to AMD, and then to your startup today. What are the highlights? Like, what was the journey from there to here to there?
Yeah. Yeah, I think this is what you mentioned is, I think this is the first kind of glimpse of memories about me kind of being connected with like computing systems. And I
Yeah.
mean, when my dad basically like bought a computer, desktop computer was like Celeron, like a very slow computer. But I mean, it was pretty good for those days. But I mean, as usual, it's as everybody else started by playing some games, but got super bored with games. And I had a neighbor. His name is Losha Alexander.
Hmm.
He was into programming. He has the subscription to Hacker magazine, and we used to basically hack the internet. The internet was
Okay.
so vulnerable, so they used to like, kind of write simple attacks to different websites. So we used to kind of do that and then get excited, got into like programming, Visual Basics. Yeah, and then after that, in high school, I started like attending computer science Olympiads, like pure programming.
Hmm.
Like we started like programming with Pascal. Once kind of learned the programming, I had always this curiosity on how like computers work, right, under the hood, how processors work. I mean, it was always like a huge interest. I had always like huge interest in like a genuine like this curiosity on like how to understand how things work. I think it was fifth grade. I tried to learn assembly language. Yeah, I just couldn't, like, my brain didn't fathom it at that
That's
point.
a pretty tall order for fifth grade. Yeah.
But at that time, I just kind of put it on a pause. I mean, and when time came to pick a university for bachelor's,
Yeah.
I didn't go to like classic computer science programming. I just decided to go hardware, kind of go to understand like how computers work. There were computer engineering programs in the US. At that time, there was a program in Kazakhstan. I mean, it's still there, but they're not sending students for bachelor degrees. It's a Bolshak program in Kazakhstan. Those days, they used to send bachelor students. So I basically won that scholarship and went to Rochester Institute of Technology.
Oh, cool.
to go to study kind of computer engineering. So we did a lot of FPGA based like RTL design, Verilog, VHDL. I mean, that's when I kind of understood how like processors are designed, right? Different flows, like the FPGA flow, the ASIC flows, and all those things we learned. I studied. Upon graduation from high school, I basically decided to continue on and applied to PhD, got my PhD in West Coast in California, and also went even deeper. So I went into the microarchitecture Santa Cruz laboratory under the supervision of Jose Rinal, my advisor. So over there, I picked a topic of microprocessor verification. Basically, when you are designing a processor, right? What are the different methodology and tools we need to use to effectively verify microprocessors? Basically, making sure before you send your design to the fab, making sure that it has uh, not that many bugs, I guess, right? So, because it's a really hard to cook like a problem even these days.
And it really matters because like once it's
No
in the
company
fab, like it's yeah.
company will guarantee you that they don't have bugs in their system because it's kind of at some point becomes a risk management problem. Every company has it in mind. They try as much as possible to get rid of the bugs, but still after fabrication you still get bugs after the chip was fabricated, and it's becoming even more challenging because the designs are getting so complicated every year. It's more complicated. Yeah, basically that's exactly my PhD thesis, effective microprocessor verification. After graduation, mostly because of the family reasons, we went back home to Kazakhstan, and I got a position as assistant professor at Nazarbayev University. As you mentioned in the beginning, there is, I mean, nothing. I mean, I tried my best to kind of find companies like research groups who do something in this field, like a microprocessor design or verification. There were a few companies. Most of them are kind of near the Russian word is KNB, right? The national security companies who are doing some encryption, decryption stuff. So that was the closest that I found. In
Yeah.
fact, we're collaborating with one of the companies right now. Yeah, but there was not that much, right? So I decided that, I mean, I really deeply understand this field. Like I know all kind of how what is the exact process to kind of create a chip, right? And when I started talking to people in Kazakhstan, saying that, hey, technically we can start doing something, start contributing to semiconductor industry in Kazakhstan. Many like laughed at me, saying that, I mean, it's too expensive, it's too risky, because they have in their heads it's a
Drop
fabrication
a
facility.
$10 billion fab in
Is it-
here and that's where you start. I gotcha. But you told them about the other path or another
Right,
path.
exactly. And I said because the process is so complicated, right? I mean, you
Yep.
can just one thing and just focus on that, like teach people how to do that, and you can start like contributing, I guess, right? And I think because I had like expertise, I guess, in verification,
Hmm.
I saw kind of opportunities that technically Kazakhstan, if we teach, right, if we grow talent in Kazakhstan and teach them how to design and verify processors,
Yeah.
technically, if you have very quality engineers who are capable, I mean, I think companies will start like popping up, like we can just start getting some like international contracts, and
Yeah.
that's sort of my vision that I kind of was
Well,
trying to
I
contribute.
was really interested when you brought that up too, because I think so. I've worked on a few different projects around sort of ecosystem building. For as a country, as said, like you said, the top down sometimes sort of looks at it and says we need something in semiconductors, and you see a couple different directions, but oftentimes it's directly to we need a $1 billion fab or something like that, right? And then as you peel the onion, you sort of see all these different layers there are to the semiconductor supply chain. And it turns out like if you want to participate, actually it's almost like a startup. You kind of have to pick a niche maybe. And sometimes it's a niche you can play to your strengths too that nobody else is doing. So even verification is probably too broad. You might start like something even more narrow within that space. But it is interesting because I've heard more or less the story that you told before. Also, you mentioned that there's work on security FPGAs and encoding and decoding. I've seen that in other countries as well too. And oftentimes you'll hear countries talk about sovereignty of silicon. And in Europe, I think they talk about sovereignty of AI a lot. I was at a conference in Astana where there were some people from Europe talking about how they want European values baked in and everything. But what you described there is like owning a little bit of your own encryption is one area where it does kind of help preserve your sovereignty so that
Yeah,
you know,
exactly.
you know, internal communications are staying internal, I guess is
Right.
kind of meaning. But
Yeah, and
so,
I think
sorry, go ahead.
yeah, every country has. I mean, not sure if every country has, but in Kazakhstan we have our own kind of standards that we have to comply
Yeah.
to. It's basically there is a special algorithm of encryption that you have to implement if you want to use encryption devices in Kazakhstan. So
Really?
yeah, you have to comply
Okay.
to that certificates. You actually have to get certification from the different like entities,
Got it.
and that's why you have to kind of if you don't have like engineers who are capable of designing those kind of things, I mean, it's really hard.
It's hard to even start with a standard, let alone to implement it and like put it on a chip, I guess. Yeah. Well, so you led a team of students to design Kazakhstan's first chip last year. It sounds like the idea came from just talking to people who wanted Kazakhstan to have a piece of semiconductors, and then you led them to this attainable part of the supply chain. What was like? How did you recruit students, and how did you get people interested in this?
Yeah, honestly, I mean, it was kind of related to what I said earlier. Like when I talked to people and people were kind of like laughing at me, basically, right? It was kind of part of that, and like I think the part of like actually fabricating a chip it had a portion of like proving that. I mean, we can do this, right? If
Yeah,
we show it once, right? I mean, it's the kind of the conversation changes from from it's impossible to hey how do we scale this, right? And I mean, yeah, I think the whole idea behind it was this, but the other part of it, I mean, I wasn't hoping anything. I mean, it wasn't that I was kind of was trying hard to prove to everybody. I mean, the other part, we're just honestly, we're just having fun. So
yeah.
I was teaching a course. There were like students, some of the students in Nazarbayev University. You can usually pick them. They have this sort of intuition in system developments. And I usually like try to find those students who really like to build hardware, and we just work together. Yeah, we just work together. And yeah, then the first chip was just a like a simple RISC-V processor.
Here, I think I had pulled up a picture of it. Let's see if I can share it. Sorry. Yeah, here we go. This was this guy. Was
Exactly.
this the
Yeah,
first one? No.
that's exactly the time when we went to like we flew to China with the whole like team, and just to
Okay.
get the chips like brought up. Like we actually like brought it up, like loaded some, wrote some C code. I mean, I think we even started by writing the like coming back to my kind of childhood dream, right? We actually
Yeah.
wrote some assembly code and
You got some
this,
assembly on there.
and then we kind of went through the whole like RISC-V tool chain like compilation process and tried to compile and run this stuff.
Wow.
Yeah, it was pretty fun. Yeah.
Yeah. I I know there was at some point there was a partnership with the Beijing Institute of like they have the open source chip. So did that come later or did you start the program with that in mind? And what
Uh,
I don't think I had never heard of that before I um saw you the articles that you wrote. So like tell me all
yeah.
about that. What is that?
So this, I mean, it kind of, I mean, everything kind of happened, like naturally, kind of, right? I mean, I had
Yeah.
this idea in mind, but then things basically started kind of uh, laying out for me by itself. So I had this vision, and I was kind of looking around like internet. Hey, how can I scale talent development in Kazakhstan, right? And then I basically stumbled upon a video on YouTube. It was a video like basically a presentation from Professor Yungang Bao from uh, Beijing Open Source Computing Institute. He was basically explaining about his research developments, and at the end, he also mentioned um, the educational program that he kind
Okay.
of launched in China. I was really like kind of fascinated by that program because I think that's uh, very correct way of teaching engineering. I mean, it's basically from what the students who are entering that program, and it's not in the university, right? So anybody in China can basically apply and attend this program. But if
This is
you are
the
getting,
sorry, I saw that there was the one student, one chip initiative. Is this
yeah,
the
exactly.
same thing or
That's
is it they're both yeah,
exactly the problem. Yeah, it's basically from the name you can imply, right, that every student who enters the program has a chance to kind of get his design like taped out at the end of the program.
I
So
see.
it's like end to end, like basically from the very basic stuff like a digital logic concepts to a working processor at the end, right? So it's a 6 month program, and after I saw that video, I just didn't expect anything. Just decided to like write an email to the professor, and
Yeah,
he replied basically, right? He said, "Hey, do you want to come to China, like to Beijing, and talk about this more?" Yeah, and like in
great.
2 weeks, basically in 2 weeks, I just bought a ticket from my own pocket and just decided to talk to the professor. Very like uh, I was welcomed very nicely. Like we talked about different like opportunities based on this program, and they basically allowed us to attend that program. And once I came back to Kazakhstan, I already had students, and we said, hey, let's design a chip because we have a kind of a channel through which we can fabricate the chip now. Uh, yeah, and then we basically like designed it. They have it. I mean, the Chinese colleagues have their own kind of uh, like infrastructure to which you have to kind of comply. So we basically design our own RISC-V processor, but then we
Okay.
have to integrate to their kind of infrastructure, run it through the tests, and then yeah, they fabricate it for us. And then
Can I show I have another picture of it's you and professor
yes,
here sharing the final like hopping to the end a little bit, but you sharing the final product together. This is really nice. And I think this was at a chip forum that you put together in
yes,
Astana late
exactly.
last year too, or last
Yep,
year.
it
Sorry.
was
So
last year. The
yeah,
professor came just to kind of with his own presentations and me kind of gathering different people from the universities, kind of trying to spread this message.
yeah.
Yeah, and it came out to pretty good, I think.
And sorry, here's one more picture that I found of you with it's a great highlight holding up the chip. I like it. I This has got to be the cover here, but the so you guys ran it through the whole process. Did they put it on an MPW with other chips, or did you?
Yeah, they basically they have a partnership with local fabs.
Okay,
I mean, it's not even a local fabs. It's basically some organizations that work with the fabs. So they basically
okay,
they support uh, people who want their designs to be chipped out. Basically, they help, they support, they tell what needs to be done. Uh, and yeah, we basically got a like a small space in that like NPW and
did and so it comes back and like it comes back just like that, like it ready to go on a PCB that you can interface and run. What did your chips do? Like what kind of designs did your teams put
uh,
together?
so yeah, it's a generic RISC-V core. I mean, anything that you guys you can write any C++ program and you
Okay,
can just compile it through RISC-V toolchain and run it. It's I mean it's very flexible. It's a general purpose processor, but it's not performant like you can boot Linux and like run operating system on it yet, right? Because
okay,
right now there is an ongoing effort kind of based on that design, kind of working on a next generation.
good.
I'm a huge believer that I mean you have to start with something and then improve.
Yeah, no, it's definitely iterative. I think it's probably amazing for those students just to go through the process once, right? The 0 to 1 is probably amazing, but you're right. It's like to get there, you got to go iteratively. You know, I think like like we talked a little bit about the importance of computing power, and probably Kazakhstan, just like almost every other country, is thinking about like sovereignty and chips and the importance of computing power lately. On like on the national level, I know there's like the national AI level here where there's a national AI program. Someone in Astana recently bought a bunch of NVIDIA GPUs to support local initiatives. Do you think there's like hope for something similar in semiconductors that like this gets a little steam and it builds more interest from the government, or yeah, what direction
Yeah,
do
I
you think
mean,
this
when we
goes?
talk to government people, there's some existing mechanisms in Kazakhstan that you can basically use. You apply, and
Yeah.
they give you a grant. Is correct. So
Yeah.
like after this whole thing happened, again, just to kind of emphasize, right? We didn't expect anything. As you mentioned, my Instagram page, right? I mean, I just like we're just shooting video, and I just compiled it. I just posted. Didn't expect anything, but it
Yeah.
just exploded. I mean, people started reposting it, and then media, like different, like actual, like pretty serious blogs and like media, like institutions started writing articles
Yeah.
about it.
It's a good story. Yeah, of course.
Yeah, and then like people started coming to universities, like shooting me on the televisions. The photo that you showed like earlier also was like part of that collaboration. I mean, it became viral, I guess, right?
Yeah.
But yeah, and after that, I mean, once that kind of we made that noise, kind of, right? Hey, we designed first chip in Kazakhstan, right? I mean, it started kind of like conversations kind of smoothed out a little bit, right? I mean, before people kind of were looking at me and laughing, but now we kind of showed that we actually can do this.
Yeah.
People started pointing me to like existing mechanisms, and there is like a Ministry of Science and Education, right, in
Hmm.
Kazakhstan,
Yeah.
which, I mean, it's not very research. I mean, usually the point of those grants is do some research and publish like papers. But this is a little bit different. I mean, it's not really research. There is nothing really novel about what we're doing, right? But it's more kind of developing talent. But still, they basically said, hey, there is a program targeted funding. I mean, it's one of the like mechanisms in Kazakhstan. They said basically apply to that grant, and let's see if we can, like, we will review it, and if we see if it is okay, we'll fund you. So right now, basically, I'm kind of writing up that application, and let's see how it goes. So there is basically existing mechanisms in Kazakhstan that allow you to do this kind of things.
Well, so I mentioned I was recently in Oman, and they did something similar. So, university and a company collaborated to, I think they called the chips eventually Oman 1 and Oman 2, and very, very similar kind of project. And their idea was to train up designers that could immediately go into this company that was in Oman. So, it's really interesting to see the different countries approaching the same problem and sort of kind of iterating into similar solutions. I mean, I know that you're starting this almost entirely from academia right now, and I know there's more going on there, but it seems like a similar path in the sense that get somebody like just kickstart it, get people designing something, get a chip out there. It doesn't have to be particularly sophisticated at first, right? Because you're going to get there if you're still building it. Um, we talked a little bit about verification, and that maybe that's the path to Kazakhstan in semiconductors. Yeah, but how do you feel about that? Like,
Yeah, I
why could
think
that work
yeah,
here?
I'm a little bit biased because
Yeah,
that's like my research stuff.
it's what you know. Yeah,
But yeah, I do believe that verification, I think, has much like a lower barrier in terms of entrance into this field. I think because, I mean, if you think about it, all you have to learn is how to use tools, right? It's basically like electronic design automation field, right? The big players like Cadence, Synopsys, and Siemens EDA, right? They basically have tools, and they do provide, I mean, all of those companies do have some kind of certification programs. Again, there's some path that you can kind of train students and
yeah,
kind of gather. I mean, again, my personal opinion is if Kazakhstan will be able to like gather this critical mass of engineers who can use those tools, right? Well, we can start doing something, right? And show to the world that, hey, we do have this kind of capabilities in Kazakhstan, and
yeah,
hopefully try to get some like international contracts as a service, right? Because verification is very tricky. I mean, like big companies, they try to keep their kind of verification teams inside,
yeah,
because, I mean, they worry about their IP and stuff. But there are many other, especially in the context of RISC-V ecosystem, a lot of different startups are kind of popping up. And technically, we could be kind of a service company for those kind of smaller kind of team companies, and provide verification as a service, right? Basically, gather an expertise, like learn how to design, learn how to verify, learn about RISC-V architecture, different methodologies of how to verify processors, or maybe other designs. But if we have that kind of the capabilities, right, the
yeah.
expertise, I mean, my belief is that we can technically be like become part of this whole kind of ecosystem.
Well, I think that's how, yeah, I think that's how a lot of ecosystems have started. Like I was saying earlier, like you kind of find a niche and you build up an ecosystem that has one or two, maybe three companies, but they're all focused similarly on the same thing. You build a talent pipeline that comes out of the university, and there's a bit of collaboration between the university and those initial startups, and even a bit of a revolving door between them, and a bit of a revolving door between those three. But that an engineer who's starting out knows, oh, this is something I can do with my life and like devote some time to this skill set. And then, one of the other trends too that just keeps on happening in the semiconductor industry is increasing specification. Like, it used to be the entire process was under one roof, right? And then big riffs like Fabless kind of came out where you have design with one company and manufacturing with another, and you'll continue to see kind of splitting out, I think, with that. So there's probably I think it's a great bet, a great niche for the
Yeah,
country to
yeah.
kind of focus on and build around. But it's so just taking another step back here. You have some great academic chops. You've done some awesome stuff there. You clearly have a passion for educating people because that was the basis of the entire project there. But you also have this entrepreneurial bug that seems like it's morphed, right? It looked like somewhere in that story you started Texer.ai, which
Mhm.
looks like it has an educational component. Looks like it's got some verification stuff. You had some software projects. Tell me about that, and then tell me what else you're working on here.
I mean, the whole, I think, story started, the whole idea of like starting a company started in the context of this whole like ecosystem building, right? Because I mean,
Yeah.
the vision that I had in my mind that, okay, we do have, okay, I have any basic, I'm working in the university. I can propose some like courses on design, some verification, right? And then I think, okay, students will take it and probably like, because you don't have any kind of companies around in Kazakhstan, right? So they'll probably forget about that course like in a few years. So that's why I thought that there has to be some like a business component to this whole ecosystem. Right? So some business entity that will start kind of start collaborating, try to collaborate with different companies and try to get some real like industry projects, right? So it's basically kind of it's kind of a chicken and egg problem.
Yeah, it's the revolving door we were talking about.
Is it?
That's that's some vision though. So you're saying these things were interconnected here. Where I mean,
Yeah,
that's a pretty big vision where you're saying I'm going to lay down the academic track, but I'll also seed the commercial track as well. Sorry to interrupt. Go ahead. So Texer AI was like started with that nugget, and then
exactly. Yeah, and
yeah,
and then we basically started the company, and then I mean, basically started. Uh, I mean, asked myself a question. I mean, what can I start like kind of providing, like selling to people, right? And I basically started with my um, PhD thesis, right? Because I mean, the researching computer engineering is very kind of industry oriented. But by that time, I already started getting some good feedback. So we published our kind of whatever we were like working on. We published it to a conference, and then I wrote a PhD thesis. But I've been getting like emails sometimes that, hey, this is a good approach. I mean, it's really helping me to find like new bugs in our systems, right?
from
So I've
industry or
always
from these. You're getting these
from
emails
industry,
from.
yeah, from
Okay,
industry, yeah.
okay,
Yeah, and then I basically thought, hey, I mean, it seems like people like find this useful, so why not we kind of try to productize this whole thing? And that's how we started.
yeah,
It was very general, kind of. We entered EDA field, honestly, because we what we were building is a tool, basically, right? And that's what EDA company does, right? It's electronic design automation. We were developing a verification tool that finds. I mean, we were claiming that you can find more bugs with this tool if you were to use.
and
And
what
then, yeah,
happens
I mean,
next?
once we opened the company, we basically immediately got this local contract. I mean, the partner that I mentioned in the very beginning,
Yeah,
who were trying to do some encryption, decryption. So we pretty much immediately got some like a local like demand. I mean, not that much, but I mean, at least we got some capital
yeah,
into the system that I can start paying like salaries to my students and like kind of jump started this
yeah. That's
whole like
great.
teaching that I had, right? So because it's
Yeah,
kind of a feedback loop, right? Well, once you have some companies and you have like you're training students, if you have more contracts, you can train more students, and it just kind of grows and grows, I guess, right? And yeah, I
yeah,
mean, we opened that company, and then because I was so focused on kind of I mean, my passion, I guess, is to ease engineers' lives, right? And I mean, that's, I think, one of the things that we're trying to do for my PhD thesis is basically find bugs more effectively without making lives of verification engineers more difficult, right?
Okay.
And once AI came out, once LLMs came out, I mean, I immediately saw the opportunity, right? Because I mean, you
Yeah.
can apply that very advanced and powerful technology to verification, and I mean, it definitely can ease lives of verification engineers very, very much. And we kind of
So
started building some tools around AI, basically AI assisted verification tools. We kind of pivoted to this kind of edge, kind of.
So help me understand one thing real quick. So, as I understand it, verification is a complete like you're testing out logic and you're testing out whether circuits actually work before you put them through. LLMs are at the end of the day, they're probabilistic, right? Like ChatGPT is just running statistics in the background to suggest your next word, right? And then that's kind of the basis of the technology. I know I'm oversimplifying that a lot. Yeah, how do you square that from something that just has to be right and work logically to get value out of something
Yeah,
that's
the
kind of
usual approach. I mean, I mean, the old school kind of. I mean, things are a bit shifting right now. I think everybody, like even
yeah,
Cadence, Synopsys, Siemens D, are trying to include some sort of AI into their toolings right now. But I mean,
yeah,
usual approach is not to use LLMs as kind of a. I mean, they also try to make LLMs write like actual Verilog code, right? Actual design things.
hmm,
What we started with was the debugging, right? Because debugging is one of the most kind of bottlenecks for verification engineers. I think
yeah,
around like 40. I mean, there's some statistics even more than 40% of the time of verification engineer is usually spent on debugging, right? I mean, it's a lot of hours and it easily gets converted to kind of money, right? And if you can kind of improve that, uh, you can, I mean, ease engineers' life very well on this, right? I mean, what
yeah.
LLMs are really good at is
It's probably
understanding.
also like the least fun. It's not also expensive, but it's probably the least fun part of your job. Maybe I don't know. So
Yeah, well, I mean, maybe engineers love because debugging is really sometimes it gets like a game, I guess, right? It's kind
that's
of
fair.
a small
Okay,
small investigation, I guess, every day.
yeah,
But LLMs are really good at understanding semantics. And I mean, what I immediately understood that we can use LLMs for debugging purposes, right?
yeah,
We didn't made it understand the actual logic behind the whole architecture. But what we did, we basically made LLMs read some like logs, right, that are generated from the simulations, right? And based on that, you can kind of guide engineer in the right direction, basically again probabilistically tell that, hey, most probably the bug is over there, right? So there
okay,
again, there's nothing exact in the verification. You basically kind of uh, narrowing down a problem for a verification engineer and kind of allowing him to find bug much more faster.
yeah,
It was one of the tools that we kind of started with when LLMs came out, and then NVIDIA started publishing some benchmarks. So NVIDIA has a good like verification team for their
mm,
GPUs, right?
mm-hmm, mm-hmm.
And they started publishing some benchmarks. We kind of showed that our tools are we're doing pretty well on on those tools. I mean, on those benchmarks.
Yeah.
But the thing is, then Claude Code came out. Claude Code, Gemini, like from Google Gemini CLI came out, and it turned out, I mean, those things are kind of are already good enough to kind of solve those kind of things.
Oh, really? Wait, so you're saying like those are good enough to really the LLM models behind them could be used directly to
Yeah, yeah. Because I
be
mean, it's I honestly I was fascinated. We're kind of doing this experimental kind of. We're running some experiments, trying to kind of compare our
yeah.
tools to kind of pure Claude Code or Gemini CLI, and those things were kind of really nice. I mean, they as I said, they're really good at understanding semantics.
Okay.
They read the code, and
Hmm.
then they have this good kind of engineering kind of reasoning behind Claude
Wow.
Code. It's more abstract, which you don't have to be like a precisely niche like verification engineer to kind of understand those things. So it starts kind of putting some print statements into the Verilog code, it generates a log for itself. It reads it and then it basically tries to pinpoint a result, like a bug based on the logs. So it basically became pretty good. But then I mean, because this debugging tool was one of the tools that we're developing. And then there was another thing that we encountered a lot, which was a hallucination problem, right? Because the mechanism, how those benchmarks are evaluated, didn't really capture the problem of hallucination. But if you really wanted to solve things like purely in with LLMs, and because you kind of mentioned it already, I mean, LLMs are very probabilistic,
Yeah.
and they need to reason about some sort of constraints, right? And there is a lot of constraints in hardware design. I mean,
Yeah.
especially if you're doing some sort of formal verification where you need to kind of define constraints. And then if you want to ask a question from LLM, basically about some truth about the design,
Hmm.
it gives you an answer, but it hallucinates, and then it basically kind of lies you confidently and tells you why it thinks it's correct. That became an issue, and we basically started like looking into this. I mean, and we also
Yeah.
noticed in general the whole AI kind of started also talking about this hallucination problem.
So just from this particular application, it would hallucinate a bug within, or it would hallucinate a bug, send an engineer over to look for that bug, and there was no bug. Like just like
Yes, yes,
just
yes,
like you hear about it hallucinating about language and other stuff. Okay. Okay, got it. So yeah, so that's a real problem. That's right. I can see that being a time waster for anybody trying to verify their engineering.
yeah. And then yeah, and I'm not sure if I want to like go on. Basically, I mean, once we identified this problem, and by that time I was already like in the Bay Area. I took a break from the university.
Yeah.
Yeah, moved to the US, to Silicon Valley, to Santa Cruz, very close to my professor who was advising me, Professor Rina.
Hmm.
And we just kind of, I mean, I met him every day. We were just like exchanging ideas, thinking about different things. And I remember talking about this hallucination problem. And he had basically an idea how we can solve this, right? And basically the reason based, the kind of the evolution of Dexter AI, I would say,
Yeah.
it's kind of addressing this specific problem. Because
Okay.
we found a solution for this hallucination, but for the constraint based like problems, right? And then we understood that this formal verification is not the only place where constraint based problem could be solved, right? So
Yeah.
we there's like like a scheduling, timetabling problems. There's a lot of constraints over there, and then some logistic supply chain problems. There's a lot of constraints over there. So if you want to
Okay.
ask a question,
So you sort of stumbled into the problem of hallucination at Texture AI, where you were doing design verification, and then as you talked more and more about the problem, you realized this kind of hallucination is a problem for
exactly,
similar fields
yeah,
that have like a correct answer or have like a logical answer, right? And you figured you could try to solve this for all of
yeah,
those fields as well.
yeah,
Okay.
yeah. Pretty much, yeah. Because I mean, we just realized that hey, I mean, I mean, if you if you ask an LLM, like I usually give this example because it's really easy to understand. I mean, what I mean by constraint problem is, I mean, is really nicely modeled by a Sudoku puzzle, right?
Okay.
I mean, because Sudoku has
Sudoku.
like
Okay, got it. Yeah.
a 9 by 9,
Very
like
logical rules to it. Yes.
yeah, so it
Yeah.
has like a 9 rows, 9 columns, and
Yeah.
9 blocks, right? And it has to have like every time it has to have only one kind of number in each row, each column, or each block, right?
Yeah.
So
Very
these
strong rules.
simple rules,
Yeah.
you have to comply with those rules, right? But even on those simple problems, the current LLM sometimes can hallucinate. I mean, I remember like putting
Huh.
like copy and pasting from like hard Sudoku puzzle to Gemini,
Yeah.
and it puts like two numbers in the same row, and basically starts explaining, you know, hey, here is the answer, and then it shamelessly lies to you about like it is correct. I mean, this is a very simple, like only 3 rules, right? And
Yeah.
already LLMs have issues like kind of handling those kind of problems. But if you have like thousands of different, like 1,000 different like constraints that you have to comply with, right? That you have to follow, um,
Yeah.
like
It
a
gets a lot
timetable.
easier to
Oh,
lie about that.
exactly, yeah.
Yeah.
So
And harder to see the lie. Yeah.
and the problem is that for the person who needs the answer, right? Or person or an agent, right? Because again, I'm envisioning like a million of different agents trying to solve different like constraint-based problems in a few years.
Yeah.
You can't tell basically. I mean, because LLM are probabilistic, it's a feature, right? It's not a bug. It
Yeah.
basically gives you the best guess, and there is no way to kind of check if the answer is correct or not, right? And what we kind of our solution is, and again, we're kind of looking through this. We're looking at the AI sort of from the hardware kind of verification kind of point of view, right? Because I mean, we've been kind of solving this complex verification task way before AI, right? And now this AI again came out again like a very hard, like a complex system that gives you some outputs. And I mean, how do you verify that the answers that is giving it to you are actually correct or not, right? So we are leveraging on formal verification, right? So there's some techniques from formal methods, some basically libraries that we leverage. I mean, whatever LLM gives you, we're not making LLM to compute, right? We're
Yeah.
basically using LLM just as an interface, and then allow this like 5 or 6 decades of research tools, right,
Yeah.
to actually compute the answer, mathematically proven answers, and then give that answer back to the LLM, right? So
Okay.
we're not making LLM to solve. We basically kind of offloading actual compute problem to reason based. I mean
Okay.
that's what we that's
And
what
that's
we do.
what reason based will do. So if I were to sort of read that back to you real quick, there's a whole section of thought or logical tools that you use in verification, design verification for semiconductors that can be applied to like you take that, they can use that to verify the work of an LLM in other sectors or on other problem
Yeah.
spaces, I
I mean,
guess. Is that right?
it's not necessarily semiconductor, because I mean, semiconductor field has been using like formal method tools for a while, right?
Okay.
It's,
Okay.
it's not necessary. It's like formal methods. It's like I mean, it goes way back to like the history, I guess.
Yeah.
Again, it's just that
Got it. Yeah.
it could be applied to software. It could be applied to hardware. But now, but I believe that hardware people has been using formal methods way more than anybody else because
Okay. Yeah, that makes sense.
they're really good at like finding tricky bugs, right?
Okay. And so what is the space that you think you like uh reason base is going to go look for a new space to apply this into? What's the first one or what's like the most interesting space for you to apply it
So
to?
I mean, we have to start somewhere. So we started trying to find some partners in supply chain at this
Okay.
point. Yeah, because it seems much more bigger. I mean, bigger market than just EDA tools, right?
Yeah.
Because
Yeah.
yeah, we just start. But again, verification is still my passion. I think I wanna like the cool thing about reason base is that you kind of you can build up vertically and then basically add different domains as you go. You can expand. So we're
Okay.
right now again. I'm starting small
Yeah.
with the supply chain field. Right, it has
Yeah.
pretty good market. I think if we can find so some partners, we can basically help them to find to use basically LLMs
Mhm.
and agents in their operational workflows.
Okay.
I'm not sure if you noticed, but I think that the trend right now is that people are trying to use this agentic flows in their workflows more like
Yes.
more right. So that I
Yeah.
think the if last year, for example, LLMs were just kind of a convenience tools that allow you to write emails better. But right now, it's honestly there's some people putting it into the flows and making LLMs to make actual decisions, real
Yeah.
world decisions. And those if they hallucinate on those decisions, I mean, it's basically it will cost you. It will be like a real world kind of. It will have a real world effect, basically, right? In terms of
Yeah, for
money,
sure.
time, and what the the open call came out, right? I mean, everybody's trying to kind of
I
use
love the
open.
discussions around the open cloud stuff. Yeah. I don't know what to make I don't know how seriously to take that. I got a little distracted and did not pay much attention, but for sure, I could see that being, I could see that
But
being
yeah,
like you
the
make a
idea is that
mistake
if you have
there.
that
Yeah.
agentic flow and you have some sort of constraints uh, that you have to follow, right? That you have to don't. I mean, you basically need to. You basically, I mean, the simple example, you're like, if an agent is allocating some resources based on the orders, I mean, you don't want to over allocate, basically, right? You don't want to give some, and there are actually some like already some cases that when agents are kind of giving too much kind of discount to a user or allocating something that is not existing, right? So those kind of things, reason-based I think can help. Once LLM asks to kind of solve this problem for them, right? You basically makes sure that it gives you a set of rules that needs to be needs to be complied by, right?
Yep.
When we use kind of formal method tools that kind of compute it as we go, we compute it, and then making sure, and we're giving like mathematically provable answer, right? So you can actually track what the agent decided, basically, right? What was the decision made by the agent? So we're kind of building infrastructure around it, that like people or other agents can basically look at the infrastructure and audit the decisions that were made.
Yeah. I find that really like it's a whole fascinating area where there's this human, like the human LLM interaction and how you, first of all, make sort of like giving the human superpowers to do more quickly. I mean, that's essentially what an agent does, because you're giving them the tools to, rather than complete the loop, you're saying just go, here's the button, like figure it out and then complete the loop for me. But then also you need to have some feedback where you can go and understand the reasoning within it and then put down guardrails or start to develop guardrails based on that reasoning. Onto supply chain, is this what suppliers are picking to go into their products, or they're evaluating risks to their supply chain? Where does it come down to
I mean, because
for
a lot of
decisions?
hopefully I mean, once we find a partner, I think we will go deeply into their operations and basically build our own library, right? So the idea
Yeah,
of reason base is that every domain will build our own proprietary, I guess, set of libraries for specific domain, right?
yeah,
And because LLMs are so good at generating code, we'll use, I mean, I guess the idea behind like a backend of the reason base is that we use our proprietary libraries to generate code with our libraries, right? And then provide mathematically provable answers, right? But I mean, the supply chain like field from like a basic research that I made. I mean, there are also basically a lot of constraints that you have to kind of comply with. I mean, if you're sending some sort of parcel, I guess, from Kazakhstan to United States, for example, right? How it can fly, right? I mean, if it's a big uh, package, right? Uh, can you send it uh, by railroads, right? Or can you send it through the simple roads, right? Or the air. I mean, all of those kind of different like minute details you have to kind of comply with.
yeah. Starting even on routing, it becomes non-obvious. Are you shipping a rocket or are you shipping a little trinket? And then does it have
Yeah,
liquids? A lot of questions in there. That's great. Well, I want to check in soon and hear how that's going. Wish you the luck there.
appreciate
Cool.
it.
Well, Nursultan, thank you so much for coming on and chatting about everything from semiconductors in Kazakhstan to LLMs and supply chains. Nursultan Kabylkas, reason based. Thanks for coming on to the Siliconomist.
Yeah, appreciate it, John. Yeah, no problem. My
Yeah.
pleasure. Thank you so much.